Hello friends, welcome to CEC live lectures. Dear friends, in our continuation with our previous lecture, Relational Database System, today also we are going to talk on the topic, but specifically we are going to talk on database models. And for the discussion on the topic, we have with us in our studios Dr. Pavitra Bharadwaj. Dr. Pavitra Bharadwaj is Assistant Professor in Department of Computer Science, Jesus and Mary College, University of Delhi. Dr. Bharadwaj has immense experience and her expertise in the area would definitely help you in understanding today's topic in detail, that is database model. So let's welcome our guest Dr. Pavitra Bharadwaj and let's try to understand what are those models of database systems, that is the database models. Hello ma'am, welcome to the lecture.
Thank you. Good afternoon. In continuation with our discussion on database models and database management systems, we are today going to talk about the different database models that are available and that are prevalent as commercial database packages. Now basically, what is a model? When we use the word model, we mean it is a prototype or it is some kind of a basic, you can say it is a mold using which other products or the final products will be created. So basically, a data model is a conceptual structure using which databases will be created, database management systems are built. So basically, data model is a framework using which we build database management systems. Now when we talk about database models, we talk about two different types of models. One is the conceptual model, which talks about what a database has to do, and the other is an implementation model, which will talk about how it is to do what it is supposed to do. That is, that talks about the details of the implementation of the model. So basically, a database model, we will be talking about different models. Three different models are used, out of which two are not used as much now, which have become more obsolete. And the third model, that is called the relational data model, is one of the most commonly used, professionally used and commercially used database management system package, which is available and which is used by both academics and businesses as well. So we will be starting with our lecture. Here we talk about what is a database model basically. So it is a collection of different kinds of frameworks or different kinds of objects together which constitute the database model or constitute the database finalized database product. So it is a collection of logical constructs which is used to represent the data structure and the data relationships found within the database. So two categories of data models, as I just said, are conceptual models, which focus on the logical nature of the data representation, and these are concerned with what is represented rather than how it is represented. The second category of data models is the implementation models, which place emphasis on how the data are represented in the database or on how the data structures are implemented. Instead of what are the data, they will talk about how these data are implemented. So basically, we will be talking about three types of data models. The first data model that was used was hierarchical model, then came in the network model, and the third model which is used now is relational database model. So hierarchical and network database models are now not used as commonly, and these have now become obsolete. The relational database model is the commonly used model presently. So this slide shows a simple example of a hierarchical model. In this we can see that each element of the database is represented in the form of a node, and each node is then subdivided into child nodes. So basically, there is a parent-child relationship between the objects of the database. So we can see here a department is subdivided as courses and students, then courses can be further studied as having constituted of professors, etc. So basically hierarchical model shows a parent-child relationship between the different entities of the database. But this model is difficult to implement also because there can be other types of relationship other than parent-child relationship among the entities. Also this model becomes very complex and cumbersome after a particular number of data items or after a particular number of objects for which data is to be stored in the database. Therefore, this model, the hierarchical model, is not commonly used for building up professional databases. The next model that is studied is called as the network model. In the network model, as we can see, the department is related to the student is related to the professor as well as the courses. So we can see here that the different objects within the database, they are interrelated to each other, and these or there can be multiple relationships between the different objects. So this can be implemented using pointers or lists, or we can say like it is something like a linked structure where each node points to the other related node. Again, this model is a very cumbersome and complex model to implement practically, and also with the growing number of objects in the database, it can become very difficult to retrieve data or to add data into any of these nodes. Each of these nodes are connected to each other, so there is also a difficulty in maintaining the connections or maintaining the records of all these pointers which point to the different nodes. Therefore, because of the problems that are pertaining to these two models, that is the network and the hierarchical model, the third model which came up was the relational model. So the relational model was basically developed by a scientist called E.F. Codd. Now Codd formulated a different kind of model to be used for databases. In this case, all objects for which data needs to be stored are represented in the form of two-dimensional structures called tables, which are also known as relations. Now this two-dimensional structure represents an entity set. Now the term entity here means any real world object for which data needs to be captured and stored in the database. For instance, if we are building a database for a bank system, what are the different objects for which you would like to capture data in a bank? In a simplest form, we can say these could be the customers or the account holders in the bank, the employees in the bank, data about accounts, data about loans, data about the managers, etc. So in this case, all these will form the different entities of the database, and each of these entities will be represented in the form of a two-dimensional structure called the relation or the table. Therefore, this database is known as a relational database. Moreover, each entity will be related to the other entities in the table or in the database. Therefore, there is a relationship between two or more than two tables within the database or entities within the real world. As we see, different entities are interconnected to each other. So we can see that different objects in the database will also be related to each other. So now we are going to discuss the relational model at length. So the basic structure of the relational database management system allows operations in a logical environment. So in this, the relational database is perceived as a collection of tables, as I just said. Each table consists of a set of series of rows and columns. The tables are related to each other by sharing a common entity or a characteristic, and the relationship type is often shown in the relational schema. A table yields complete data and structural independence. So basically what we are saying is that you will capture data about all the entities in the real world and put them as tables inside the database. Now each table will have a set of columns and a set of rows, as we know that a table is a two-dimensional structure which has rows and columns. Now in this case, the columns will represent the characteristics or the properties of the particular entity that you are capturing the data about. And the rows will be called as the instance of the particular entity. So, if there are 1000 students in a college, then the student table in the database will have 1000 rows, each row representing a unique student within the system or a unique entity within the system. So, the table itself is known as an entity set, and each row of the entity set or each row of the table will denote an entity instance. Now, there is complete logical and structural independence in case of a table, because you can easily change the structure of the table without having the need to change any of the programs that access the table. And also there is no need to understand the way this table will be stored physically on the computer's hard disk. So, therefore, the programmer or the database engineer or the designer is completely ignorant about the physical aspect of storage of data in the form of table in the computer on the computer's disk. Therefore, we say that it is a completely logical and structural independence among the data which is stored in the form of tables. Then a relational database in this case, which is managed by a system, is known as a relational database management system, and a relational database holds different types of objects like tables. It will have queries, it will have forms, reports, macros, etc. So, these are the different objects which are the component objects of a relational database. So, we can see that in an RDBMS we have its own terminology. The different table elements are denoted as the attributes, the columns are known as the attributes, and the rows are known as the tuples. So, this is a relational database terminology where we will call columns as the attributes or fields and rows are known as records or tuples. So, one database can hold many tables. The tables can hold different kinds of data. Data can be linked between the tables, and the link between the tables is known as a relationship. Now, different tables are related to each other with a common attribute. That common attribute is one single element in each of the table which belongs to some other table. So, this common attribute actually acts as a link between the two tables. This is known as the key attribute. We will be discussing about keys in a short while. So, in this diagram we can see that different tables are there in the database. You have the department, you have the courses, student and professors table, and the common element or the common field in the different tables, like for instance department number is present in the professors table, and in the courses table also you can see department number is there. Professor ID is present in the professor table, it is also present in the course table. Similarly, course ID is also present in the students table. So, we can see that these are repetitive fields which are present in different tables. So, these fields become the common attributes which link one table to the other, or which create a relationship between the two tables of the database. So, in this case we can see that this common attribute is the primary key of one table, which will be used as a foreign key in the other table. So, what is a primary key? A primary key is any attribute within the table which is used for unique identification of records, or which is used to identify rows in a table uniquely. Like for instance, in a college situation, each student has a unique roll number. You cannot have two students within a college who have the same roll number. Another important condition with the primary key is that it should be not null. That is, you cannot have a student in the college who does not have any roll number. So, it is essential that each student must have a roll number and that roll number must be unique for each student. So, this kind of an attribute which is used for identifying of entity instances uniquely is known as the primary key. Now, this primary key from one table can be used in another table and there it is known as the foreign key. So, foreign key is that attribute which is associated or which is the primary key of some other table and which is existent in this table. So, therefore, this key or this attribute or this field will become that attribute or that possibility of creating a association among those two tables which share this common attribute. So, when we say that these two tables are related, when there is a common attribute between the two tables. So, certain records in the two tables are related to each other. Which records are related? Where the value of the primary key matches the value of the foreign key. Those records are said to be related to each other. So, we have the ability to relate records in multiple tables and this ability gives the relational databases its power, because you can fetch data from more than one table at any given point of time. This data can be combined. You can combine the data from the different tables and you can get a report or you can get your results from the cumulative database. So, actually the table is a logically independent structure, but since all the tables in the databases are related to each other or are associated to each other, so basically it becomes a large cumulative structure from which logically data can be fetched at any given point of time. So, these relationship what we are talking about is the association between these two tables. Now, these could be of three different types. The first type of relationship is known as a one-to-many relationship or a parent-child relationship, where one record in the table is associated to more than one record in the other table, but each record in the associated table will correspond to only one record in the other table. Like for example, we can say that each person can have more than one child, but each child has one parent, one father or one mother. So, commonly this type of relationship is known as a parent-child relationship, where one record in the primary table can be associated with more than one records in the related table, and each related record corresponds to only one record in the primary table. So, this type of relationship is known as a one-to-many relationship. The second type of relationship that we discuss is a one-to-one relationship. A one-to-one relationship exists when one record in the primary table is associated with only one single record in the other table. So, this type of relationship is known as a one-to-one relationship. A one-to-one relationship is created using by linking the primary key of the two tables. The third type of relationship is known as a many-to-many relationship. A many-to-many relationship could be something like each employee learns many skills and each skill is learnt by many employees, where more than one record in one table is linked with more than one record in the other table. So, this type of relationship is known as a many-to-many relationship or many-to-many association. So, in this case what happens is that more than one record in the primary table will correspond to multiple records in the related table. An example of one-to-many relationship could be a author writes many books, but each book is written by only one author. An example of one-to-one could be each employee manages one bank and each bank branch has exactly one manager. So, this could be an example of a one-to-one relationship. Similarly, you can look for multiple examples in your real world. Like for example, if we have a system where each college is managed by only one principal, so then that will be a one-to-one relationship, because each college is managed by a principal and one person or one teacher can manage only one college. So this is again an example of a one-to-one relationship. But the relationship between, for example, student and course, each student studies many courses and each course can be studied by multiple students. So this type of a relationship between student and course will be many to many relationship. Similarly, we can have different examples in the databases where we see different types of relationships are emerging. Some of these relationships we will see practically also we are done, but relationship like many to many is not supported by few commonly used RDBMSs like Access, etc. So in this we can see how a one-to-one relationship has been shown. Each record in one table is associated with only one record in the table B. In the next slide you can see this is a one-to-many relationship where one record in table A is associated with multiple records in table B. So similarly you can see record 2 has 2 corresponding records in the table B, but each record in table B corresponds to only one record in table A. So this type of a relationship is known as a one-to-many relationship. And this type of a relationship where multiple tables are related to each other can be shown here. So here you have an association of 4 tables with each other. So this is a perfect scenario of a database, relational database management system, where you see that tables are associated to each other using different types of relationships, different cardinalities of relationships. Now we will talk about a few key terms which are commonly used in the RDBMS scenario. The first is entities and attributes. Now entity is a person, place, event or thing about which data is collected, and attributes are the characteristics or properties of that entity. Now table holds the related entities or an entity set, and tables are also called as relations. Tables are comprised of rows and columns. So we have already discussed these terms, that all real world objects for which data will be captured and saved in the database are known as entities. The table becomes a combination or a set of different entities, so it is known as an entity set, and each row within the table can be known as a record or a tuple, and each represents entity instance. So these are the common terms that will be used when you are talking about relational database management system: entities, attributes, tuples, relations, fields, rows, etc. So in this case we can see different entities are there, like for example student. Now the attributes of student could be student ID, name, course, date of birth, address, mobile number, email address, etc. Similarly, if you have teacher, teacher will have the properties like teacher ID, name, date of joining and so on. Then you can have other entities also. It is also important here to understand that entities may not only be tangible entities, we can have intangible entities as well in the database, like for instance exam. Exam is an intangible entity, but still data is to be stored about the exam. So therefore, we have data about tangible entities as well as intangible or logical entity. Like you can store data about a classroom, which is a tangible entity, but you can also store data about the class, which is an intangible entity. So different entities have their existence in the database in the similar manner. Similarly, when we will talk about attributes, different types of attributes are there in the tables. We can see you have attributes like single valued attributes and multi-valued attribute. A single valued attribute is an attribute which will have only one single value, like date of birth, whereas you can have multi-valued attributes like mobile number, for which a user can give multiple values or more than one value. So, you have single valued attributes and multi-valued attributes. Similarly, we can have simple attributes and we can have composite attributes. Simple attributes are those for which you cannot divide them into further components, whereas composite attributes can be divided into more than one components. So, like for example, address. Now, address can be further subdivided into house number, street, city, country, state. So, therefore, address becomes an example of a composite attribute, whereas something like email address cannot be further subdivided into components, therefore, it is known as a simple attribute. Then when we talk about attributes, there is another term which we commonly see, that is known as the domain of an attribute or domain of a column or field in a table. Now, the word domain refers to the range of permissible values which are allowed for a given attribute. For example, if we say that the minimum salary of an employee in an organization will be rupees 10,000 and the maximum salary would be rupees 10 lakhs. So, in this case, the domain for the attribute salary will be 10,000 to 10 lakh. Or if we say the domain for the attribute name will be a combination of all English language letters. So, all uppercase and lowercase letters will form the domain of the attribute name. So, basically domain refers to the values which can be given to a particular attribute. So, in this we are seeing the different terms which are used for, like for example, you use table, then in the set oriented approach you use the term relation, then in the record oriented we use the term record type. Similarly, we use the term tuple and record for a row and attribute and field for the term column. So, different terms can be employed or different terms are used for different kinds of fields in different languages, like the set oriented approach or the relational approach or the table oriented approach. So, different terms are used. Now, next we are going to talk about some important topics or some important elements of a relational database management system which are known as the keys. So, key word basically refers to an attribute which is a prime attribute in the table. So, key consists of one or more attributes that determine other attributes. So, primary key is an attribute or a combination of attributes that uniquely identifies any given entity or row in a table. So, primary key, as we said, cannot be null, like student ID or ISBN or Aadhaar. Key's role is based on the concept of determination. Now, the concept of determination is how an attribute's value can be determined given the value of another attribute. So, this topic of determination we shall be continuing in a short while from now. Thank you.
Thank you so very much for giving us this session on database models. Dear friends, we will be back after a short break, so you are requested to be with us. Thank you. Hello friends, welcome back to this session. Friends, as you know that today we are talking on database models, and for the discussion on the topic we have with us in our studios Dr. Pavitra Bharadwaj. Dr. Pavitra Bharadwaj is constantly and continuously giving us information about the database model, as we have discussed in the previous session also. So friends, there is a lot more for you. Be with us, and we would like to welcome our guest Dr. Pavitra Bharadwaj once again. Hello ma'am, welcome to the lecture.
So, as we were discussing about the topic of keys in relational database management system, so the first important key that we discuss when you talk about relational database management systems is the primary key. So, primary key, as we have discussed, is that attribute which will be used for unique identification of records within a table. So, the primary key attribute is an attribute which is unique and which is not null, that is, it has to have some value, you cannot leave it blank. For instance, we have the student ID, or we have the account number in the banks, or we have the patient ID in the hospital, or we have the library number, accession number for books in the library. So, all these numbers are unique numbers which are used for identification of records in these tables uniquely. Then we talk about another key that is known as a composite key. Now, in some tables we will find situations where it is not possible for a single attribute to be made as the primary key, because no single attribute qualifies the two conditions of uniqueness and being not null. So, in that case what we do is that we combine two or more attributes to create the primary key. Such a primary key which is composed of two or more attributes is known as a composite key. Now, the composite key could be where both the combination of the two attributes has to be unique and neither of them can be null, because it is a part of the primary key. So, you cannot have it null, but it has to have a unique value. The combination has to be unique. So, the two attributes cannot have the same value for any two rows in the given table. So, such a key will be known as a composite key. Then there can be situations in a table where you have more than one attribute which qualifies to be the primary key, or which fulfills the condition of being unique and not null. So, in that case what happens is that the database designer chooses one of those key elements or key attributes to become the primary key, and the others which qualify or which are eligible to be the primary key, they are known as candidate keys, because they are eligible to be the primary key. So, they are known as the candidate key. Then sometimes we have also seen situations where there is a specific attribute which is used only for data retrieval or searching purposes. Like for instance, at many places, say in a hospital, many a times we see that when patients do not remember their unique identification number given by the hospital, you are asked your mobile number. So, mobile number in this case is a key or is an attribute which is only used for data retrieval and searching purpose within the database. This type of a key is known as a secondary key or an alternate key. So, secondary key is an attribute or is a field or is a property of the entity which is only used for finding out or searching or data retrieval purposes in the database. So, we will just go through the definitions of these keys that we have just now discussed. So, a composite key is composed of more than one attribute, as I just said, and all these attributes, when no single attribute can uniquely identify records, then you use the composite key. For example, in case of a books issued, so you need a composite key like the accession number and the date of issue. Together these will qualify to be the primary key. Then we have a super key. Super key is any key that uniquely identifies each entity, any attribute or combination of attributes which can be used by identification of records in a table. So basically a super key can be one attribute, two attributes, or all the attributes of the table put together. And a primary key is a minimal super key. Minimal super key means that it has the minimum number of attributes which are required for unique identification of record. For instance, in a table if you have 4 fields like student ID, student name, student date of birth and course. So in this case you can have a super key as student ID, another super key as student ID and student name, another super key as student ID, name, date of birth, and there can be yet another super key student ID, name, date of birth and course. So all these 4, that is individual as well as combinations, can be called as the super key. But primary key out of these will be only student ID, because that is called as the minimal super key. That is, that has only that many number of attributes present which are required for unique identification, and no extra attributes are present in case of a super key. So super key and primary key, there is a relationship, that primary key is the minimal super key of the database. Then we have foreign key. Now foreign key, as I said, is the primary key or an attribute whose values match the primary key values in the related table. Then we have the candidate key, where a field or attribute which qualifies to be the primary key is called as the candidate key, and secondary key like the mobile number is used strictly for data retrieval purposes. Now when we talk about keys, there is another important term which needs to be discussed, and that is constraints. Constraints are those rules or those limitations which are put on the database to maintain the integrity of the database, so that the data in the database is always in the correct and consistent form. So in case of primary key, we say that it is entity integrity constraint that needs to be enforced. Entity integrity constraint means that no 2 rows in the table will have the same values for all attributes. That is, the primary key value in the 2 tables has to be different. Then when we talk about foreign key, we talk about referential integrity constraint, or we talk about the constraint of referential integrity, whereby we mean that if the foreign key contains either matching values or nulls, the table make use of such a foreign key are said to exhibit referential integrity. This means that a foreign key field can have only those values which match the primary key values in the table to which it is related, or null values. So it means that the data in the 2 tables will be consistent in at all times in all stages of the database. That is, if you delete an item from the primary key, then that item, the related records in the foreign key must first be deleted. Otherwise, it will leave the data in an inconsistent state. Secondly, if you update any of the fields in the primary key, then all the related records in the foreign key column have to be updated accordingly. So therefore, this constraint is known as referential integrity constraint, that is, the foreign key always refers the primary key. The foreign key will only have those values which are there in the primary key column of the primary table or the associated table, or it can have null values. If no values are present, then it can have null values. And also we enforce that whenever there is a delete or an update in the primary key, then an equal or a cascading effect should take place on the columns of the foreign key. Otherwise, if this is not happening, then the data in the database may not be in an integrated and consistent form at the given point of time when these constraints have been violated. So all relational databases must abide by the 2 constraints, that is entity integrity constraint and referential integrity constraint. Then we talk about the concept of dependency. Now, dependency means that a key helps to define entity relationship. The key's role is based on a concept known as determination, which is used in the definition of functional dependency. So, an attribute B is said to be functionally dependent on A if A determines B. An attribute that is part of a key is known as a key attribute. A multi-attribute key is known as a composite key. So, if the attribute B is functionally dependent on a composite key A, but not on any subset of that composite key, the attribute B is fully functionally dependent on A. Now, what we are trying to explain in this is that there is a concept of determination. That is, if you know the value of one attribute, can you determine the value of the other attributes in the table? This is true only for the primary key. That is, given the value of the primary key attribute in a table, you can determine the value of all other attributes in the table uniquely. But the opposite or the vice versa of this is not true. For instance, if I give you the value of a student's roll number and I ask you the value of the name, you can return a unique value. But if I give you the name of a student, will you be able to give me a unique value for roll number? No, that is not possible, because you can have more than one student who has the same name. Therefore, we say that primary key attribute determines, or key attribute determines, the other non-key attributes of the table. And along with this, we also use the term determines, we also use the term functionally dependent. That is, all non-key attributes are functionally dependent on the key attribute. So, basically determination and dependence are related to each other. The key attributes are dependent, the non-key attributes are dependent on the key attributes, and the non-key attributes are determined by the key attributes. But we have seen that at times the primary key is actually composed of more than one attribute. So, in that case, the scenario is that the dependence will be on the complete primary key and not on its subset, that is on the entire, or if the primary key has two attributes, then the dependency of the non-key attributes will be on both those attributes. In that case, it is said to be fully functionally dependent. Fully functionally dependent means that the non-key attributes are functionally dependent on the complete primary key and not a part of it, not a subset of it. Therefore, we say that key attributes determine non-key attributes and non-key attributes are dependent on the key attributes of the table. So, in this we can see a simple relational database diagram is shown to us, where we have two tables and these two tables are linked to each other with the help of a common attribute called the vendor code. Now, the next topic that we are going to talk about is about relational database operators. That is, how relational algebra, how it determines or how it supports the relational databases. So, relational algebra basically defines the theoretical way of manipulating tables contents using different relational functions, which are select, project, join, intersect, union, difference, product and divide. So, in these slides we will be talking about each of these functions, each of these relational operators individually. So, the first relational operator that we are going to talk about now is union operator. So, we have seen that union operator means that you will combine the data of the two tables. So, union combines all rows from the two tables and the two tables must be union compatible. Union compatible means that the tables should have the same number of columns and the domain of the columns should also be same. Only then you can combine the data from the two tables. So, union operator will combine or will add the rows of the two tables. The next is intersect operator. The intersect operator works more like the set intersection operator, which will find out the only those rows which appear in both the tables. So, again the tables which you are choosing for intersection must be union compatible, that is the type, number and the domain of the attributes within the two tables should be same. So, then you will get only those rows which are available or which are common to both. So, union is going to add the rows and intersection is going to give you the common rows of the two table. The next operator that we discuss is the difference operator. In case of difference operator, you will get the rows which are present in the first table but not present in the second table. So, basically you get the rows, the difference of the rows in the two tables. Again, for finding out the difference between the two tables, the two tables must be union compatible, that is they should have identical number and type of columns in their structure. Then the next operator is the product operator. In case of the product operator, as you can see, each row or each tuple in one table will be combined with each tuple in the other table. So, if there are 2 tuples in the first table and 3 in the second table, so as a result of these you will have 6 tuples in the resultant table. You can see in this diagram also, when you are creating a product of the two tables, you see the columns are being added and the resultant table has 5 columns and 6 rows. So, this is creating a combination of the elements or the combination of data values within the tables using this type of a relational operator. Then the next operator that we discuss is the select operator. The select yields values for attributes found in the table. So, basically select will give you a horizontal subset of the table. In case of select, you take out only those specific rows from the table that follow your criteria. So, select operator, this is not the select operator that is used in the normal SQL queries, but this is a relational operator which will fetch only the selective rows from the given table. The next operator is the project operator. In case of the project operator, what you get is a vertical subset of the tables within the database. Vertical subset means that you will get a few specific columns from the table, not all the columns but a few specific columns of the table. So, you will only find out in case of a project that you can fetch specific columns. Now, when you are doing in case of SQL select statement, what we are doing is a combination of select and project, because in that case what we do is that we give the names of the columns that you want to be given out from a table, and you also specify a criteria of filtering the rows. So, that statement is a combination where you are doing 2 operations at the same time. One is the project, that is you are filtering the filtering the table vertically, only a few columns can be selected, and you also specify the condition which will help you segregate only a few rows, which will help you take out only a few rows from the table. So, basically you have select and project combined as a result of this operator. The next operator that we discuss is a join operator. Now, join is the operator which gives the relational databases its power, because you are able to combine information from 2 or more tables, and this is used in independent tables which are linked by common attributes. So, we have seen that the tables in a relational database, they have common attribute, that is the primary key in one table is present in the form of the foreign key in the other table. So, there is where there is a common attribute between two or more than two tables, you can easily combine the data of the two tables by using the join operator. Now, the join basically is a complicated operator which has 3 steps. In the first step, a product of the two tables is taken out, that is all rows in the first table are combined with all the rows in the second table. As I just said, if there are 3 rows in table A and 4 rows in table B, so the first step will be to calculate a product. So, you will finally get 12 rows in the result. The next step will be to select the rows which follow the condition of equity, that is which follow the condition of commonality of the common attribute, that is the value of the primary key in one table will match the value of the foreign key from the other table. So, only those rows out of the 12 rows, for instance 12 rows will be taken out that where the values of the two common attributes in the two tables will match. Then in the third step, what is done is a project operation where the duplicate columns are removed, because the common attribute is coming from the two different tables, the primary table and the related table. So, in this case a project will be taken out, and as a result for the user the common column will be shown only once. So, therefore, the join operator is actually a 3-step process. The first step is a product, the second step is a select, and the third step is a project operation. So, now we will see how these operations take place, and this type of a join is known as a natural join, which links the tables by selecting only the rows with common values in their common attributes. So, it is a result of a 3-stage process, as I just said, a product of the two tables, then a select is performed, and then a project is performed. So, you can see here you have the step 1 where a product of the two tables is combined. So, in this case you have two tables, one is the customer table and the other is the agent table. So, the combination of all these rows of the customer table is done with the agent table. Then in the next step what you do is a select statement where you check the condition where primary key becomes equal to the foreign key. So, here you can see only those rows are selected where the value of agent code in the customer table is matching the value of the agent code in the agent table. So, these two values, wherever the values are matching, only those rows have been selected. And in the third step it is a project where the agent code column is removed and only one instance of the agent code column is remaining. So, the result that you get is a join of the two table, that is the customer and the agent table have been joined for the values which are there in the customer table. See, agent code in the agent table is the primary key and in the customer table it is the related or the foreign key. So, wherever these two values are matching, there this kind of a connection is established and a join is created. Now, besides the natural join that we have discussed now, there are other types of join also. Like for example, you can have an equi-join. Now, in case of an equi-join, the thing is that the condition is remaining. The condition of equity is enforced just like in natural join, but the duplicate columns are not eliminated. In natural join, the last step is project, whereas in equi-join, this step is not there. So, the duplicate columns are not removed in case of an equi-join. Then there is another type of join which is known as the theta join. Theta join is a join where this condition of equity is not there. In fact, only those rows which have greater than or equal to values, such condition can be applied in case of a theta join. So, other than equal to. Then there is an outer join also. In case of an outer join, the rows which do not match are taken. So, in case of natural join, it is the matching values of the common attribute, but in case of an outer join, the values are taken which are not matching. So, it is the opposite of the natural join which takes place in case of an outer join. So, besides the natural join, we have discussed that we have equi-join, we have theta join, and we have an outer join. So, these are the different relational operators that are present in case of a relational database management system. So, now these relational operators basically they provide a theoretical way or a theoretical background of creating a language or query language for the relational database management system. This query language is known as the structured query language or the SQL. Now, this SQL language has its roots from the relational operators that we have studied, but it has got a wide number of commands which are present. So, structured query language is a standard language which is used by most RDBMS packages. So, today we have discussed about the different data models which are there. Along with that, we have talked about the relational data model at length and also the different concepts of keys and other related concepts like constraints, etc. So, in the next lectures, we will be talking about the structured query language and the various commands that are available in that language to manipulate data in the various relational database management systems. Thank you.
Thank you, ma'am. Thank you so very much for giving us this lecture on database models. Dear friends, if you have any query or feedback, then do write to us at info.cec@nic.in. We will be meeting again soon and would be discussing some other new topic. Till then, take care. Goodbye. Thank you. Thank you once again.